kids, so today we're going to talk about standard deviation and interpreting standard deviation within the context of a problem. We're going to go back over what we did yesterday, finding mean, median, min, max, Q1, Q3, range, IQR, all in our calculator, and we're going to talk more about what that means in context of problems as we did yesterday. So what you should do right now before we get started is check over your answers from last night. I put the answer key that looks like this on Google Classroom, so you should check over your answers both front and back. All right, I'm not going to show you the answers now. You should do that on your own. Check your answers and then come back here and we're going to get started on this. So the first thing we're going to do is we're going to start with the introduction, which is a white sheet of paper. It should have been a white individual sheet of paper, and you guys are starting to write the numbers, which is great. But the whole point is to understand what is going on. So what we're going to do is we're going to start with this first column right over here, and I'm going to kind of like introduce what standard deviation is. So in this first column, it says the following data describes the annual salaries in thousands of dollars. So here's a dot plot that represents the data that's shown here. So a dot plot is just a visual way to represent data. It actually can kind of tell you some more information just by looking at it. A dot plot can tell you which number has the most amount of things, how it's spread out, if it's evenly spread out, or if it's spread over only a couple of numbers. So it's a nice way to kind of give you an idea and an understanding of what the data is telling you. Now, in here, I've given you the answer of mean, and then you're going to see down here another answer. But we're just going to put this in. I'm just going to give you some more practice so that you can go back and look and remember how to do this. So again, turn on your calculator. All right, hit the on button, and then you're going to hit 5 buttons: second, then plus, 7, 1, 2, and then research your calculator every time so that we can put new data into our calculator so we don't screw anything up. So now, to put this data, 25, 30, 35, all this stuff over here that I circled, into our calculator, we hit these buttons. Ready? We hit stat, and then we go to edit. We just hit enter right away, and now we have our columns. So you're just going to type in your data. After each number, you're going to hit enter. I guess I got to click them all in. All right, and all you're going to do is you're just going to type in all of your data. Now, once you've done this, once you've typed in all your data, you go back to stat, and you go over to the top right where it says calc. So you use your arrow to go over to calc, and then 1 bar stats. This is all the same exact stuff we did yesterday. So you hit enter at 1 bar stats. Now if you have a new calculator, it will show like you got to hit enter a couple times or scroll down to calculate. Older calculators, all you have to do is hit enter and bam. Now I must have put something in wrong because that doesn't look right. 30, 35, 35, 35. Oh, see, my data's wrong. I only put in 145. So my data's off. Hopefully you put in the correct data because this is what it should be. Go over to calc, 1 of our stats. Instead of 39, it should have been 40. So your X bar or your mean is 40. Now, here's the new thing we're going to talk about today. You see this little symbol right here? It looks like a little O with a line against it, an X. This is called standard deviation, this guy right here. So I'm going to show you what the symbol looks like. All right. So this, it's like an O, and then with a line up there, and then an X. This is standard deviation. And standard deviation, this is what we're going to talk about today, is found on your calculator. We're not going to do it by hand. Standard deviation is the distance that the average or the majority of your numbers are going to be from your average. So since our average in this, we're talking about salaries, if our average salary was $40,000, because it's talking about in thousands of dollars, if our average was $40,000 and our standard deviation we found to be 8.9, that means that on average, a typical employee salary, and notice how I put this right here, is plus or minus. That means if you add 8.9 or subtract 8.9, that's the range, or that's, and I don't like to use range because range means something different in math, but that's the basically the spread, how far apart the majority of the people in the company's salary will be. So it really is going to fall in between. If you went 40 plus 8.9 is 48.9, all the way in between, and then 40 minus 8.9 is 41.1. So the standard deviation of 8.9 means that, not 41.1, sorry. It is early. I'm doing this at 5 in the morning. I apologize. All right, 31.1. So an average salary that falls between 31.1 and 48.9. This is where the majority of the people will fall in between. And if you look at the data, that makes sense. If you look up here, 25, 30, 35, 35, 40, 40, 40, 40, 45, 45, 50, 50. All right, the majority of the people are going to fall in between here and here. Look, there's only three people whose salaries don't fit inside there, but the majority of the people fall in between here. And that's called standard deviation. And that's what we're doing today. So if you were to do this set of data over here, which is what I want you to do, all you're going to do is you're going to go back to your calculator and go stat, go to edit. And the only thing that happened, it says the data from the left was adjusted. Sorry, you can't see. So that a new employee was hired and their salary was also included. Here's the new person's salary. Now notice that new person's salary is really big. It's a lot bigger than everyone else's. So what we're going to do is we're just going to go back to our table. We're not going to clear anything out because I'm just trying to show you something. And we're going to fill in this new person's salary, right here, of 70. So you're going to go, after you type in 70, you're going to go back to stat. You're going to go over to calc, 1var stats, and we're going to find our new mean, which you should get 4.31 or 42.31 up here, your X bar. Now look, your standard deviation also changes to 11.7. So with this new person added, who was a larger salary, if you look at it, it changes both our average salary and then the range that our majority of salaries should fall in between. So that means that our range now with this new person added, the majority of people's salaries will fall in between 53.31. That's on the high end because you're adding 11.7. And then if you subtract 11.7, this is going to be 30. Basically, it's like 30.6. If you look, that should make sense. 30.6, that actually does not include the 30 anymore. And here. So, again, the majority of people fall in between the standard deviation, the plus or minus 11.7 from the new average. All right. So that's what we're talking about today. Today we're going to analyze standard deviation and talk about how that's going to help us really give some idea and some understanding about where the majority of people lie. Um, I was taught in high school that standard deviation is like the meat of the burger. You have a little bit of bun over here, you have a little bit of bun over here, but this is the meat, this is the substance, and that's what comes from the standard deviation. When you add and subtract that standard deviation from your mean, it's the meat of your burger, the meat of your burger, and here's the bun. Those are the things that just don't fall in between. So, what we're going to do right here, all right, we're going to adjust the salary one more time up here, all right? So I'm going back to my calculator. We're going to adjust the salary. So go back to stat, go to edit, and you can scroll down a lot like easier than I can. I don't know why mine's going really slow. But we're going to type in one more salary. We added the owner's salary of $95,000. Now, you can see my answer, but if you keep thinking, if we added a new salary the last time, it changed my mean, my average. If I had a salary of 95,000, by adding another salary, especially a very large salary, that should change your mean, which should change your standard deviation. So you put that in, hit enter. So now we go to stat, calc, one var stats, and now look, you get an average of 46.07 and a new standard deviation of 17.66. It's really 6.5, whatever. But notice this new standard deviation, all right, gives us a bigger range of data. This is telling us that now, oh man, the majority of the meat of our data is going to fall in between. If you go 46.07 plus 17, that's going to be 63.73. That's on the high side. And then on the low side, 46.07 minus 17 is roughly 23 point something, whatever it is. But anyway, if you look, this now with this owner salary, it now incorporates this 25 and it goes all the way up here. So look at that. Now with this new owner salary in here and that newest person that was just added in, their salaries aren't included with the standard deviation. The meat is now a much bigger picture. So as the range increases, all right, meaning that as we start adding more people and as we start adding people that are further away from everyone else, all right, our standard deviation becomes farther from the mean. We start getting a larger standard deviation. We start incorporating more and more things because what we're doing is we're adding things that are a lot larger. We call these things outliers. They're kind of changing and skewing our data. So outliers can kind of give you a false idea of really what's happening. They're kind of giving you a bad sense of what's going on in the problem. So as you start adding in these outliers, either big ones or small ones, your standard deviation will either become farther and farther and spread out more and more, or they're going to shrink and not really incorporate everything. So the big thing today is knowing that standard deviation, the symbol O with the line X, which is, if you look at your calculator, is when you get your one var stats, it's just above the N. You see the O with the line and the X? That's your standard deviation down there. That tells you how far on average the typical data point is above or below your mean. All right, so it kind of gives you your meat where the majority of your points will lie. You're going to add the standard deviation to the mean and then subtract it from the mean, and that gives you your spread, how far apart the majority of the people are. So today, that's really the new thing, is using that and understanding what that means. So what I'm going to do is I'm going to show you the next problem. So now we're in our notes. All right. I'm going to cover that up because many of you are going to start writing and stuff. All right. So when we start comparing centers and spread, there are two different things that are there. So a center, which is a way to like compare a middle. There's two types of centers. There's a mean. A mean is a center, and a median is a center. When we deal with data, you are given both, like your calculator will find you both, but you only use one or the other. And we're going to talk about when you use one or the other when I come back. But it's important, and I show you this right now, that when you choose the specific center to use, you're only going to use one type of spread to determine where the majority of your data is going to be. So if you choose mean, and I'll teach you when you choose the mean, you're going to use standard deviation as the way you show the majority of the people, or find where the majority of the people lie. If you choose median, you will choose IQR. IQR is really the distance Q3 minus Q1. So the upper median minus the lower median. Clearly, IQR deals with the median. So those are connected. So when we do problems and we really start getting into the meat and like heavy statistics, you're going to learn to choose one or the other as the way to represent your data. When I come back, I'll teach you how to do that and when we'll do that. But right now, I just wanted you to see that mean and standard deviation connect together clearly. Standard deviation tells you how high and below your data is from the mean, the average, and IQR tells you, well, the distance between your upper median and your lower median, Q1 and Q3. So here we go. On your yellow sheet, you have standard deviation. It represents the average distance between individual data points and the mean. Yep. You add it and subtract it from your mean and tells you basically where the meat of your data will lie. Now, this is a formula how to figure it out. Guess what? You're not doing it by hand, so don't worry about that. Now, because I'm one, doing this on a calculator, and two, I'm not in front of you, it's silly for me to type this into my calculator and do it, because what you can do is you have my screenshot of how I got onto my calculator and how I put the points in and did all that stuff. You're going to do a bunch of these examples, and what I want you to do is you're going to pause when I tell you to pause, type in your data, and then I'm going to show you what data you should get, okay? So, in this first example, the following data describes the number of pairs of shoes owned by several people, determines the centers and the spread. So centers are mean and median, spread is IQR and standard deviation. So, what you're going to do is we're going to first take our calculator, and because we've already done some data and we got a new problem, we're going to hit second plus 712. And if you're like, oh my God, I don't even remember what he just said, pause, rewind the video a little bit, and listen to what I said again. So now what I want you to do is go to Stat, hit Enter at Edit, and you're going to type in all this data. I am not going to do that. I've already done that. But you're going to do that, and then I want you to go to Stat. Again, once you type it in, go over to Calc, 1-bar Stats, and I want you to fill out your table below. All right? Pause the video, do that, and I'm going to show you the answers in a second. All right, so this is what you should have gotten. You should have gotten a mean of 7.25. You should have gotten a standard deviation of 3.5. You should have gotten a median of 7.5. And then the IQR doesn't tell you what the IQR is, but IQR is Q3. Q3 minus Q1, and 10 minus 4 is 6. So, lovely. We have that on here. So now, today we're going to talk about statements about standard deviation and statements about IQR. Well, we learned that standard deviation gives you the meat of your data. So that means your standard deviation is 3.5, meaning that if we add 3.5 to our mean and subtract 3.5 to our mean, that's where the majority of our data will lie, which is why I wrote this. Most people have 3.5 pairs of shoes above and below the mean of 7.25, which means most people have between 10.75 and 3.75 shoes, or pairs of shoes, because you add 3.5 to 7.25 to get 10.75, and then you subtract 3.5, and that's how you get that. So this is where it kind of spreads between. the majority of the people have between 3.75 and 10.75 pairs of shoes. Now, something I didn't say yesterday is what the IQ actually means, IQR. Well, the IQR of 6 means that about 50% of people, all right, 50% of people have between 4 and 10 pairs of shoes. So between your Q1 and your Q3, 50%. So this 50% is almost like majority. Actually, your standard deviation covers more than 50%. Standard deviation is almost like 67%. And you're like, how did you come up with that? I'll explain when I come back. But it's more. Your standard deviation covers more than the IQR. But IQR is exactly 50% of people, and it tells you where they range from. They range from 4 and 10 pairs of shoes. And your median is your middle, and not necessarily the middle of 4 and 10, but it's your middle number after you cancel out low and high. So the statement about your IQR is 50% of people have between 4 and 10 pairs of shoes. So there's 6 shoe sizes 6 shoe pairs that they range between 4 and 10. So that's what we're doing today. We're finding our data and then putting some understanding between standard deviation and IQR. All right. So now we're going to do our second example, which is on the backside. Now we did this yesterday. This is the bowlers. All right. And we did some of this. So what you're going to do is you're going to put in each bowler individually. Caleb first, then Kim second. All right. So you got to do one and then the other when you fill out your table. All right. So again, go back to your calculator and go second plus 7, 1, 2, and you're going to have to restart your calculator 2 times for each set of bowlers. And then you're going to fill out the values, and then we'll talk about what this is. So pause it, fill out the values, and then start it up when you're ready to go. All right, so here we go. So you should have gotten for Caleb a mean of 150.125 and a standard deviation of 2.7, and a mean for Kim of 146.25 and a standard deviation of 27.7. Now, here we go. So if we did a statement about this, so most of the scores that Caleb had were 2.7 points above or below this mean score. So if you want to talk about somebody being consistent, this guy Caleb is very consistent, because that means that most of his scores will be somewhere between 147 and 152 or 153. So if he falls in between 147 and 150, well, really, it's like almost 3. There's only like 6 scores that he would majority, for the most often have. 147, 148, 149, 150, 152, 153. That's awesome. That basically because his standard deviation is so low, that he's probably going to be in this area. You have a very, very, very good idea of what this guy's going to do. Whereas Kim's mean is 146, which is fine. It's lower than Caleb's average. They're lower, but the standard deviation is 27.7, meaning that Kim's majority of scores will fall between, if you subtract 27 from 146, it's like 119. That's on the low end. And then on the high end, 146 plus 27 is 173, or really it's 174 when you add in the decimals, right? But it's like, holy cow. So on average, the majority of his scores are going to fall in between 119 and 147. That's ridiculous. That's like 53 scores that this guy could possibly have, whereas Caleb will score really only 7 different types of scores. So consistency, Caleb is consistent. Consistent. Kim is kind of wild. I'm not sure what Kim's going to do. It's hard for me to know what Kim's going to do because of the standard deviation. It's so big. So I can't really tell you what's going to happen, but I will tell you that Caleb, will be really close to these scores, whereas Kim, I have no clue what Kim's going to do. Now, median, so median, when you talk about this, median is 150 and our IQR is 5, meaning that 50% of the scores for Caleb will fall. So with an IQR 5, they're going to fall between 147.5 and 152. And for Kim, because your IQR, look at how big this IQR is, 39.5, means that all of the data is so spread out all over the place that 50% of the scores fall between 130 and 169. And I got these from the Q1 and the Q3. So I got these from these scores. This is my Q1 and this is my Q3. Same thing here, Q1 and Q3. That's how I got these scores. 50% of your data will fall in between here. So 50% of the data is going to fall between these 5 scores, whereas 50% of the data is going to fall between 39, almost 40 scores. That's crazy. That's so not consistent. That means that this guy is very, just erratic, not sure what they're doing. So that's not a really good thing, especially, if we start getting into serious things like money and stock market. If things are fluctuating by this much rather than something that only goes up and down little bits, this is a very dangerous and scary thing to work with. Whereas a 5, something that only goes up or down, 5, that's not scary at all. That's something very consistent, something that I feel comfortable working with. All right. So hopefully this is kind of making some sense. Oh, and there's the range. So if you look at this range from the low to the high of the data, you can clearly see Caleb, his consistency, this range just says it all together that, hey, the low score and the high score only range by 8 points, whereas Kim's low score, high score range from 86 different scores. That's nuts. That's a really, really spread out set of data. All right, so those were your notes. So what I'm going to have you do right now is get a little more practice before you start your homework. All right. Now, if you're at the end of the class period and you're like, wow, it took me a long time, go get your homework from the sub, all right, and start working on that. I will show you the answers to that tomorrow. If you're done early, you should get some more practice doing this right now, all right? So I have some, no brain break, classwork. So what you can do is you can take a look at the answers to make sure that you have this, all right? So you can check this out. You can always pause your video, all right? And you can check this out. I only want you to do one of these problems and then you're going to start your homework, okay? So do your homework, make sure you're doing it the same way as we're doing these problems, and hopefully this understands, and I'll be back tomorrow to answer any questions.